Article 374.7 in the National Electrical Code, or NEC, addresses the spacing of lug terminals within panel boards and switchboards. However, it does not govern the spacing of lug terminals on transformers. When determining the minimum spacing between lugs on a transformer, several factors come into play. These primarily include the transformer's voltage rating and the specific type of lug connector being employed. For transformers operating at 600 volts or less, a general guideline specifies a minimum spacing of 0.25 inches between terminals. In contrast, for transformers operating above 600 volts, a minimum spacing of 1 inch between terminals is typically required. However, it is crucial to recognize that these are general guidelines. The manufacturer's installation instructions for the transformer in question take precedence and must always be consulted. These instructions provide specific spacing requirements tailored to the particular transformer model. The National Electrical Code provides comprehensive guidelines for electrical installations, ensuring safety and standardization. Article 374 specifically addresses auxiliary gutters, which are enclosures used to supplement wiring spaces at meter centers, distribution centers, switchgear, and similar points. While not directly applicable to transformer lug spacing, understanding Article 374 can provide valuable context for general wiring practices. Section 374.7, titled Spacing of Bare Conductors, focuses on the spacing requirements for bare conductors within auxiliary gutters. This section mandates specific distances between bare conductors based on voltage levels. For example, for systems with 300 volts or less, a minimum spacing of 0.5 inches is required. For systems exceeding 300 volts but not exceeding 600 volts, the minimum spacing increases to 1 inch. These spacing requirements aim to prevent accidental contact between conductors, reducing the risk of short circuits and electrical hazard. While Article 374 primarily addresses auxiliary gutters, the underlying principles of conductor spacing are relevant to various electrical installations, including transformers. Maintaining adequate spacing between conductors is essential for ensuring electrical safety and preventing equipment failures. The National Electrical Code provides detailed tables and guidelines for determining appropriate conductor spacing based on voltage levels and environmental conditions. These resources should be consulted to ensure compliance with safety standards and best practices. While 374.7 focuses on auxiliary gutters, the general principle of spacing conductors based on voltage applies to other electrical equipment, including transformers. The specific requirements for transformer lug spacing may be found in other sections of the NEC or in the manufacturer's instructions. The manufacturer's instructions are always the primary source of information for specific equipment, as they are tailored to the design and specifications of the product. In addition to conductor spacing, the NEC also addresses other aspects of transformer installations, such as grounding, overcurrent protection, and ventilation. These requirements are designed to ensure the safe and reliable operation of transformers in various applications. Grounding is essential for preventing electrical shock hazards and providing a path for fault currents. Overcurrent protection devices, such as fuses and circuit breakers, protect transformers from damage caused by excessive current flow. Adequate ventilation is necessary to dissipate heat generated by the transformer, preventing overheating and potential failures. The NEC provides detailed guidelines for each of these aspects of transformer installations, ensuring compliance with safety standards and best practices. Consulting the NEC and the manufacturer's instructions is crucial for ensuring a safe and reliable transformer installation. When installing or maintaining transformers, it's essential to consider several key factors to ensure safe and efficient operation. Firstly, proper grounding is crucial. Grounding the transformer helps to protect against electrical shock and provides a path for fault currents, minimizing the risk of damage to equipment. Secondly, overcurrent protection is vital. Installing fuses or circuit breakers of the appropriate rating will protect the transformer from overloads and short circuits, preventing costly damage and potential hazards. Thirdly, ensure adequate ventilation. Transformers generate heat during operation, so providing sufficient airflow around the unit will prevent overheating and extend its lifespan. Fourthly, maintain proper clearances. Keeping the area around the transformer clear of obstructions will allow for easy access for maintenance and inspections, and will also help to prevent accidental contact with energized parts. Fifthly, use appropriately sized conductors. Selecting conductors with the correct ampacity rating will ensure that the transformer can operate at its full capacity without overheating or causing voltage drops. Sixthly, tighten connections. Regularly inspect and tighten all electrical connections to prevent loose connections, which can cause arcing, overheating, and potential failures. Seventhly, follow manufacturer's instructions. Always adhere to the manufacturer's instructions for installation, operation, and maintenance of the transformer to ensure optimal performance and safety. Eighthly, perform regular inspections. Conduct periodic inspections of the transformer and its associated components to identify any signs of wear, damage, or potential problems before they escalate into major issues. Ninthly, keep records. Maintain accurate records of all maintenance activities, inspections, and repairs performed on the transformer to track its performance and identify any recurring issues. Tenthly, train personnel. Ensure that all personnel who work on or around the transformer are properly trained and qualified to perform their tasks safely and effectively. For transformers operating at 600 volts or less, a general guideline specifies a minimum spacing of 0.25 inches between terminals. In contrast, for transformers operating above 600 volts, a minimum spacing of 1 inch between terminals is typically required. However, it is crucial to recognize that these are general guidelines. The manufacturer's installation instructions for the transformer in question take precedence and must always be consulted. These instructions provide specific spacing requirements tailored to the particular transformer model. Let's delve into some specific scenarios to further illustrate the importance of adhering to manufacturer's instructions and relevant codes. Suppose you're working with a 480-120/208 volt step-down transformer commonly used in commercial buildings. This transformer falls under the 600 volts or less category, so the general guideline suggests a 0.25 inch minimum spacing between terminals. However, upon consulting the manufacturer's documentation, you discover that they specify 0.375 inch minimum spacing due to the specific lug type and insulation characteristics of their product. In this case, you must follow the manufacturer's requirement of 0.375 inches to ensure proper insulation and prevent potential short circuits. Conversely, imagine you're dealing with a medium voltage transformer operating at 4160 volts. The general guideline for transformers above 600 volts calls for a 1 inch minimum spacing between terminals. However, the manufacturer's instructions for this particular transformer model mandate a 1.5 inch spacing due to the higher voltage and the need for increased insulation to prevent flashover. Again, you must adhere to the manufacturer's stricter requirement of 1.5 inches to guarantee safe operation. Always consult the manufacturer's documentation and local electrical codes to ensure compliance. These resources provide detailed specifications and guidelines tailored to the specific equipment and installation environment, ensuring that all work is performed safely and effectively. Regarding transformers, numerous resources can provide valuable information and guidance for safe and efficient operation. Firstly, the National Electrical Code, or NEC, published by the National Fire Protection Association, or NFPA, is a comprehensive set of standards and guidelines for electrical installations, including transformers. The NEC covers various aspects of transformer installations, such as grounding, overcurrent protection, and wiring methods. Secondly, the manufacturer's documentation for the specific transformer model is an indispensable resource. These documents contain detailed information on installation, operation, maintenance, and troubleshooting. Always refer to the manufacturer's instructions before performing any work on a transformer. Thirdly, industry standards such as those published by the Institute of Electrical and Electronics Engineers, or IE, and the American National Standards Institute, or ANSI, provide additional guidance on transformer design, testing, and performance. These standards can be helpful for understanding the technical aspects of transformers and ensuring that they meet industry requirements. Fourthly, online resources such as manufacturer websites, industry forums, and educational websites can provide a wealth of information on transformers. These resources can be helpful for finding answers to specific questions, learning about new technologies, and staying up to date on industry trends. Fifthly, local electrical codes and regulations may impose additional requirements for transformer installations. Be sure to consult with your local electrical inspector or authority having jurisdiction, or OJ, to ensure compliance with all applicable codes and regulations. Consulting multiple resources and staying informed about the latest standards and best practices is crucial for ensuring the safe and reliable operation of transformers. The information provided offers a solid foundation for understanding transformer lug spacing and related considerations. However, it is essential to remember that this is not a substitute for consulting the NEC, manufacturer's instructions, and qualified electrical professionals. The NEC provides comprehensive guidelines for electrical installations, ensuring safety and standardization. Manufacturer's instructions offer specific details tailored to the equipment you are working with, while qualified electrical professionals possess the expertise to interpret and apply these resources correctly. To summarize, when working with transformers, the following steps should be taken. Firstly, always consult the manufacturer's installation instructions for the specific transformer model you are working with. These instructions provide critical information on lug spacing, torque requirements, and other important details. Secondly, adhere to the minimum spacing requirements outlined in the NEC. These requirements vary depending on the voltage rating of the transformer and the type of lug connector being used. Thirdly, ensure that all lug connectors are properly sized and rated for the conductors being used. Using undersized or improperly rated connectors can lead to overheating, arcing, and potential failures. Fourthly, tighten all lug connections to the manufacturer's specified torque. Over-tightening or under-tightening connections can compromise the integrity of the connection and lead to problems. Fifthly, perform regular inspections of transformer lug connections to identify any signs of looseness, corrosion, or damage. Address any issues promptly to prevent further degradation and potential failures. Sixthly, when in doubt, consult with a qualified electrical professional. They can provide expert guidance on transformer installations and ensure that all work is performed safely and in accordance with applicable codes and standards. This comprehensive approach will help to ensure safe and reliable transformer installations.